Introduction to column. Column are the most important structural members of a building which transfers the load from beams and slabs. Many failures happen due to the failures of columns. A plain concrete column can support very little load, but its load carrying capacity will be greatly increased if longitudinal bars are added. The additional of normal ratios of reinforcement may increases 15 to 40% of the total carrying axial capacity of the columns. Lateral ties are added to the provide to support the longitudinal bars and decrease the tendency of the bars to buckle out during the loading. They also avoid the concrete from expanding laterally, and due to Poisson's effects, the accordingly increase concrete ultimate strain. RC columns are categorized as tied or spiral type depending upon the lateral conformant type used. Tied columns are normally square or rectangular, but they can be octagonal, round, L-shaped, or any other required shape. The square and rectangular shapes are usually used because of the simplicity of the constructing the forms. Sometimes, however, when they are used in open spaces, circular shapes are very attractive. Spiral are even ensure a better holding of longitudinal bars in place, and they all also conform the concrete inside the greatly increase its resistance to axial compression. As the concrete inside the spiral trends to spread out laterally under the compressive load, the spiral and the restraint it is put into the hoop tension, and column will not fail until the spiral yields or breaks, permitting the bursting of the concrete inside. In ceramic areas, it is highly desirable to use spiral columns than tied columns. In actual practice, there are also no perfect axially loaded columns. Some amount of eccentricity will always be present due to the reduction of the size of the columns from one floor to the another, or misalignment of the columns. Hence, minimum longitudinal reinforcement ratios has to be provided to account for any stresses resulting from the eccentricity. RC columns are generally classified as short or long columns based on the length to width ratio and end restraint conditions. Short column failure due to initial material failures. The load that can be support is controlled by the dimensions of the cross sectional and the strength of the materials of which it is constructed. We think of a short column as being a rather stockly members with little flexibility. The slenderness ratio of such columns are lesser than 12. Longer or slender column fails due to bending. As column become more slender, bending deformation will increase along with the secondary moments. If these moments are such magnitude as significantly reduce the axial load capacities of columns, these columns are referred to as being long or slender. The slenderness ratio of such columns are greater than 12. Short compression blocks or pedestals. If the height of an upright compression member is less than 3 times its least lateral dimensions, it may be considered to be pedestal. In this chapter, will focus on our attention in design of short axial loaded columns. General aspects: behavior, strength of columns. The failure of tied columns are usually initiated by spalling of concrete cover followed by the buckling of longitudinal bars due to the lack of lateral support provided by the cover. The failure of axial loaded columns are brittle and sudden, with the vertical cracks starts appear with the concrete cover failure, leading to collapse of the columns. In spiral reinforced columns, the spiral stirrups and vertical bars confine the concrete very effectively. As results, the concrete covers will spiral, but the core will continue to carry load larger than initial load that cause spalling. The spalling of cover gives a warning of failures, and shortly after that the column will reach another maximum load, but under very large deformations. Design parameters: like these are the two major factors governing the column designs. One is bracing. If the column can sway, addition moments are generated through the P minus delta effect. This does not affect the braced column. Second one is very important: slenderness ratio. The effect length divided by the lateral dimensions of the columns is called slenderness ratio. Low values indicate a crushing failures, which high value denote buckling.